created an extra review so that you can really determine if you're ready for this Chapter 6 exam. So I gave you the practice. You're going to hand in the practice exam, but then try this on your own and then check your answers by watching this video. So we should know instantly how to solve equations involving logarithms or exponential. So in this case, I have the common log. I want the common log to be undone. So it's base 10. I can exponentiate both sides. It's really the same thing as rewriting this in exponential form. Logs are exponents. So really what this means is 3x minus 10 equals 10 squared, which is 100. Okay, and then from there, once we got rid of the log, this should be our easy two-step equation to solve. So all you need to do, and I'll write it up here, we have 3x equals 110. I just added 10 to both sides, and then I'm going to divide by 3. 110 divided by 3 is 36.6 repeating. Okay, we keep it like that, or you can round. I have 3 decimal places. You could have 667. Okay, but I'll keep my answer like that. So for number 2, you will see this. We have 2 logs on the same side. We must condense. So with number 2, you must condense into a single log. So this means multiply. So I'm going to take x times x plus 6, and that's going to equal 3. Now I can rewrite that. So my exponent is a 3. Okay, my base is a 3, so I'm going to put a 3 underneath each. And what you're going to see is we have a quadratic equation. So once this log is gone, I distribute that x. I'm going to have x squared plus 6x equals 3 cubed, which is 27. Okay, so I'm going to get 0 on one side, and this, I promise you on the test, any type of factoring is going to be pretty easy. So in this case, I know it's going to be a plus 9 and a minus 3. Okay, so when you check, my outers and inners add up to that 6x. 9 times negative 3 is negative 27. You get an answer of negative 9 and a 3. Now, technically in this case, we would cross out negative 9 because it wouldn't check. So if I tried to check my answer to see if negative 9 actually is a solution, you'd have to take the log of a negative number. Can't do it. Only 3 is a solution. Now, you're not going to have to worry about crossing out extraneous solutions on the exam. Okay? So number 3 is just like number 1. The only difference is instead of base 10, it's base E. So I'm going to put an E underneath each side. That gets rid of the ln. And so then you just have to realize, and I'll pick up my calculator at the end to get an actual decimal, but this is the moves I'm going to have to do. Okay, so I'm going to have to type in negative e to negative 2. I'm going to have to subtract the 6, hit enter, and then divide by negative 9. Okay, so let's see what that comes out to be. Second ln, that's where my e appears. I put in my negative 2. I'll hit enter just so you can see that. But then I'm going to subtract 6 right away, and then I'm going to divide by negative 9. And so my answer is about 0.65, and I'll round that 1 to a 2. Okay, so you can see, try to round correctly. That 1 should be bumped up to a 2 because next to the 1 is a number, is 6, which is 5 and above, you round up. Okay, here, this is now an exponential equation where I need to undo this base of 9. So the first thing I need to do is get that 9, the base 9 all by itself. So we're going to just simply subtract 2. So it's going to be 55. Okay, but now my last move, and this is why we learn logs. Okay, logs are exponents. Our calculator knows what 9 needs to be raised to give you 55. So you don't divide by 9. You can rewrite this in logarithmic form. So my answer is log base 9 of 55. And we learned a while back, hit the math key, scroll up, hit enter, and put in your 9, put in the 55. I know it's going to be between 1 and 2. It's going to be 1.82, and we should round that 3 to a 4. And there's your answer. Okay? So now number 6, my base is an E, so I have 2 moves. Two moves that we must do to get that base of E all by itself. My first move is simply to subtract 5. So it's going to become a 40. I'm going to divide by 6. Now this will end up being a decimal. So 40 divided by 6 is that. I'm going to hit math, enter. And I prefer just keeping 20 over 3. So it's really 20 over 3. And then to undo a base E is simply the ln. So I just need to hit the ln of that answer, previous answer. So if you kept it as a decimal, that's fine. Paste that all in, and then you're going to get an answer. So I'll show in my notes that it's the ln of 20 over 3, and your answer is about 1.89, and this time it'll stay a 7. Okay? Easy. Need that to be easy. So you're going to have equations that took 5 minutes to solve all the equations on this paper. Okay? For number 6, you're expanding this ln, this natural log. I see 3 items, so I'm going to have ln 3 times. Okay, so the first thing we see up top is x cubed. I'm just going to write the x, and I'm going to put the exponent in front of the ln. Okay, now since the z's in the bottom, I'm going to use a minus sign, and I'm going to have the ln of z. And since the y to the 6 is in the bottom, I'm going to have a minus. And instead of writing y to the 6th, I'm going to move the 6 in front of my last log. So that is fully expanded. Okay, so I have 2 things in the bottom. That's why I have 2 minus signs. Okay, here we're going the other direction. I'm writing it as a single log. Okay, so you can see that it's a plus and then a minus. So I'm going to have a quotient. The first thing we see is that 12 in front is the exponent for the z. The next thing we see is an x, and that's also raised to the 12th power. But in the bottom, since there's a minus, I have y to the 4th in the denominator. Okay, so it should be easy to expand and condense. Unlike your quiz, I'll use the ln. Okay, so on the test, instead of using logs with other bases, we'll just use the natural log, which is base e. Okay, for this, if it's a division problem, divide your numbers like you've always done. A 3 out of 6 is really a half. Okay, and then please make sure, do not be tempted to divide the exponents. You subtract the exponents. So it's the exponent up top minus the exponent in the bottom. You get a 10. Okay, expect something like that. For number 9, you're actually going to take the number and raise it to the outside power. So when we have 3 to the 4th power, what you're going to see is it's going to be an 81. Okay, now if you can't do it in your head, ask the calculator. 3 raised to the 4th power, it's going to tell you 81. Then you have your e, and then you have to remember power raised to a power, that's when we multiply our exponents. Okay, so that's an acceptable answer. You could rewrite this so that you write it as a positive exponent. So it's okay, I'm accepting this answer, but we could also take the base of e, cross the line, change the sign of your exponent, and that's why we would have an e in the denominator. Okay, here we're doing the 1/3 power. So you should know the cube root of 27 is 3, but I could also ask 27 raised to the 1/3 power, and it's a 3. So I get a 3, but then this 15 is being raised to the 1/3, so I'm really going to take 15 times 1/3, just like I did multiplied here, but it's 15 times 1/3, which is really the same as 15 divided by 3, okay, which is 5. So I'm going to have a 5x, okay? And then finally, here I have 3 e's in a row. You just have to add your exponents. So I'm going to combine my like terms, this 12x and this negative 6x. I add together, I'll get a 6x. And then a 5 plus 8 is going to be a 13. Okay, so pretty easy. Here, I gave you 2 of these where I want you to transform e to the x. So if I tell you to do a reflection, you just put a negative sign in front, okay? Then, so it's negative e to the x So followed by translate 6 units to the left. Since it is a horizontal movement, I need to go to where the x is, which happens to be an exponent, and left, I'm going to add 6. So technically this is together, okay? As long as you write it as an exponent, you'll be fine. So negative e raised to the x plus 6. And then on the outside, to shift down, I have a minus 10 on the outside. Okay, easy. This one, I'm going to put a factor of 3, so it's a stretch. So I put a 3 in front of my e to the x. And then I'm going to follow that by a translation 6 units up. Okay, so I don't do anything with the x. The x is where I go if it's a left or right movement. Okay, so again, we've been doing those transformations all year long. Okay, next page, I'm reviewing finding the inverse. Okay, so you need to realize I want to see that you switch the roles of x and y. That's your first move. And then the second move is to undo things so the y is by itself. So since this is not in parentheses, I don't have parentheses around the x plus 6, my first move is to subtract 7. So I really have x minus 7 equals the ln of y. And now I'm ready to undo a logarithm. This ln is base e, so I'm going to exponentiate both sides. So really it's e raised to the x minus 7 is my inverse. Okay, and make sure that x minus 7 is an exponent. Okay, it's wrong if you said e to the x and then push away minus 7. That would be a shift down 7. This is a shift right. And you can confirm this on a calculator. My original function was the ln of x. So I'm going to type in my original, close the parentheses, and a plus 7, which is a shift up 7. So it's going to be up here. Okay. Remember, it goes down forever. It's going to always get closer to the x-axis. It's never going to cross over the x-axis. But its inverse, what we just said, is going to be e, so second ln, and then I have my x minus 7, which is going to be a shift to the right. So we're going to see it's over here. So, and it curves up exponentially. So we moved it from going through here over to here, but they are inverses of each other. So there's that diagonal where it would fold over. So remember, this, the domain is all reals, but my range is everything greater than 0, where my original, the domain of a logarithm is everything greater than 0. So, and the range would be all reals. So just keep that in mind when it comes to inverses of each other. Okay, then I quickly review just you solving. So we start out with 85,000 people in this school district. So starting amount is 85, but you can see it's a decay. We're decreasing by 9%. So if my base is 0.91, 9% of the population's leaving this town, and eventually our 85,000 is going to come down to 30,000. So that's what I want to see that you can solve. So I'll go through the steps of undoing so that we solve for t. Okay, we did a warm-up very similar to this with money. So to solve for this exponent, the first move is to divide by 85,000. So I'm simply going to take my calculator and I'm going to type in 30,000 divided by 85,000. You get that answer. Now, if you don't want it as a decimal, I can have it as 6 over 17. So either way, I can paste that decimal or write it in as a fraction. But once I do that, so it's easier for me to show this work as 6 over 17. But now to solve for t, who cares that the base is 0.91? I just need to ask the calculator, take the log of base 0.91 of 6 over 17, and that's going to be how many years it takes 85,000 to become 30,000. So I'm just going to clear that, hit my math key, go up to log base, put in a base of 0.91. Okay, it's a decay because the base is less than 1, and 6 over 17. And it's going to take about 11 point, and we'll keep it at 0.4 years. So slightly more than 11 years for that population to decrease to 30,000. Okay, and then a couple more, and then we're done. So here, I am giving you the starting amount. We're taking, and that's your principal, so I want to know the ending amount. So find the balance after 26 years, so that's what A is. A is your ending amount. I'm taking $75,000 to a bank. Continuous compound interest is this formula, so I just need the E. It's on your calculator. The interest, the R stands for the interest rate as a decimal, and T in this case is 26 years. Okay, so I expect to have a lot more money than what I started with. So 7,500, I type in my calculator, and then I hit second, LN, there's that E that we need, 0.0. Okay, so all we have to do is type this into our calculator. So I had the 75, there's my E, and then we have 0.0675 times the 26 years of just letting it sit in there, and we'll get an answer of $43,375, and try it around to the nearest penny, which in this case, we round that 85 to an 86. Okay, so not bad for just letting money sit in a bank. Okay, number 17, I'm going to give you a starting amount and an ending amount, and we're going to solve for the year. So we're using the same formula where A in this case is going to be 6,000. Our principal, we're only taking $600 to the bank. It's continuous, so we use that E, and we're earning 8%. So your R in this little formula is your 8%, which is 0.08 times T. Okay, so this again should be a very easy problem to solve. It takes us a couple moves. Our first move is to undo the 600 because that's not your base. Your base is E, so we're going to divide by 600. So 6,000 divided by 600, you're going to see that it's going to just be a 10. So we're taking 6,000 divided by 600, and like I said, you're only going to get a 10, but then it'll free us this, our base, which is E, raised to the 0.08 T. So to undo a base E, it's log base E, which is the ln. So we're just going to ask the ln of 10. And that gets us to, remember, logs are exponents. So it allows us to get to where that exponent was. And then we'll have to divide by 0.08. So last thing we have to do is ask the calculator for the ln of 10. It knows it. And then divide by 0.08. Okay, so I'll show that. 0.08. And it's going to take about 28.78 years. Okay, but your $600 is now going to become $6,000. Okay, and then the last, when it's a logarithm that we're graphing, our domain's going to be restricted. Okay, so I'm asking for the domain and range, and then I want a quick sketch of this. So since we should know by looking at this rule, there's no reflection, there's no stretch, there's no shrink, there's no number in front of the log, but we do see that it's x minus 1 in parentheses, so we should know it's to the right 1. And then we're going to shift up 4, okay? So we can type that in our calculator, but I'm going to tell you right now, we're going to have a guideline, a vertical asymptote, that's what the one big idea was asking about, where all our points are going to be to the right of x equals 1. So I'm just going to go to the y equals screen, and I'm going to type that in. So I have to make sure I remember the math key, scroll up the log base, put a little 6 as your base, x minus 1 inside the parentheses, push away, and do plus 4. Okay, we can see, and remember these calculators, this should point down. It's always going to get closer to a 1. It's going to stay on the right side of 1, but our range is going to be all reals because it points down forever. So I'll show that. But we'll go to our table, and we can see the first dot I can plot is 2, 4. So when x is 2, when you plug in a 2 here, you'll have an outcome of 4. and then I'll estimate, I'll go 7 up 5. That's another nice dot. So 2 dots is all I really need, and I could estimate more if I wanted. So this graph curves through these points, and then it goes down, always getting closer to that guideline, and it's always going to continue to go up. So that's why your range for a logarithmic function is all reals, but in this case, my domain must be values greater than 1. Okay, so hopefully that helps. That's everything you're going to need to know for your exam. So just an extra review. Thanks for watching.